Let's start by understanding what cloud computing actually is. It's essentially using computer services like servers and storage over the internet, instead of owning all that hardware yourself. Think of it a bit like renting electricity. You only pay for what you use. This comes with some serious advantages. It can significantly cut down on costs, lets you easily adjust your resources as needed, scaling up or down, offers high reliability, and allows you to access everything from anywhere. And while cloud providers handle much of the security side, you still need to be aware of best practices. Okay, let's talk about how cloud services are offered. It's all about service models. There are three main types: IaaS, PaaS, and SaaS. IaaS is like renting an empty office space. You're responsible for setting everything up yourself: the servers, storage, networks. Then there's PaaS, which is like renting a fully furnished office with utilities included. You focus on building your application, not managing the infrastructure. Finally, SaaS is simply using software over the internet like Gmail or Salesforce. No setup or management needed for you. Okay, let's talk about how these cloud models work differently. IaaS is like renting a bare office space. You bring everything else yourself. PaaS gives you a fully equipped kitchen. You just focus on cooking your recipes. And SaaS? That's like ordering takeout. The restaurant handles everything. Understanding which one fits your needs depends on your team skills and how much control you want over your environment. Okay, let's talk about AWS. It's a really big player in the cloud world, one of the biggest, actually. Essentially, it gives you access to all sorts of computing resources without needing to buy and maintain your own servers. AWS is super versatile. They have services for almost anything you can imagine, from running websites and apps to analyzing huge amounts of data. Some of their most popular services include EC2 for virtual machines, S3 for storing files, sync photos and videos, and a whole bunch of database options to fit different needs. Okay, let's talk about Microsoft Azure. Think of it as Microsoft's big entry into the cloud computing world. It's a massive platform offering tons of different services, essentially everything you need to build and run applications in the cloud. It's broken down into core areas like compute, where you can create virtual servers, storage for holding all your data, databases for managing information efficiently, networking, ensuring everything connects smoothly, and even powerful AI and machine learning tools. Plus, they have a solid DevOps suite to help manage the entire development lifecycle. Okay, so let's talk about Google Cloud Platform, or GCP. Think of it as Google's way of offering all the cloud services you need, from building apps to storing data and running them at scale. It really builds on a lot of Google's existing strengths. At its core, it gives you access to things like virtual machines that are super flexible, a managed service for container orchestration called GKE, storage solutions for different types of data, powerful tools for analyzing huge datasets with BigQuery, and even serverless functions for running code automatically based on events. Okay, so when it comes to the big three cloud platforms, AWS, Azure, and GCP, they all do a lot of similar things. But they started in different places and have different strengths. AWS is Amazon's platform. It's been around the longest and has an absolutely massive range of services, which can be a bit overwhelming at first. Azure is Microsoft's offering, and it really shines if you're already using a lot of Windows or Office products. They integrate super smoothly. And then there's GCP, Google Cloud Platform. They're known for being cutting edge, especially with things like Kubernetes, which is great for managing containers, and their expertise in data science and artificial intelligence. Basically, think about where your business already has existing investments and choose a platform that best complements those. Okay, let's talk about how cloud providers organize their infrastructure. First up, we have asterisk regions. Asterisk. Think of a region as a large geographic area like all of Europe or the entire United States. It's where your resources are generally deployed to be closest to your users. Now, within each region, there are asterisk availability zones, asterisk, which are completely separate data centers. They are isolated from each other in terms of power and networking, so if one goes down, the others keep running. This setup ensures high availability for your applications, a really important thing to consider when building robust cloud solutions. Okay, let's talk about virtual machines. They're super important in the world of cloud computing. Basically, a VM is like a computer program that acts like a real server, but it lives inside another physical machine managed by Amazon, Microsoft, or Google. Instead of buying and managing your own servers, you're renting these virtualized resources. This gives you tons of flexibility. You can scale up or down as needed, run different operating systems on the same hardware, and easily deploy new things without a huge setup process. Okay, let's talk about object storage. It's a really important piece of the cloud puzzle. Instead of storing files in folders like you might be used to on your computer, object storage treats each file as an individual item. It's super scalable and cost-effective, allowing you to easily store huge amounts of data. AWS has Amazon S3, Azure provides Azure Blob Storage, and Google Cloud uses Google Cloud Storage, all offering similar core functionality but with their own strengths and integrations within their respective platforms. Think of them as different warehouses for your digital stuff. Okay, let's talk about managing the computing power behind your cloud applications. AWS uses EC2 instances. Think of them as virtual computers you can customize for your needs. You manage access tightly with IAM roles. Azure has virtual machines and scale sets which automatically adjust resources based on demand. Google Cloud Platform offers compute engine with managed instance groups. Essentially, all three platforms give you ways to scale up or down as needed, balancing performance with cost efficiency. It's really about understanding the core concepts of instance types, scaling strategies, and how to optimize for your specific workload. Let's talk about auto-scaling. Essentially, it's your cloud provider's way of making sure your application can handle whatever traffic comes its way, whether that's a sudden surge during a sale or just a regular busy day. AWS uses auto-scaling groups and elastic load balancing to manage this dynamically, adding or removing EC2 instances as needed. Azure does something similar with virtual machine scale sets and an Azure load balancer. And Google Cloud Platform utilizes managed instance groups and the cloud load balancing in conjunction with horizontal pod autoscalers for containerized applications. The key is that these systems constantly monitor metrics like CPU usage and automatically adjust the number of servers to match the demand, keeping your application running smoothly and efficiently. Okay, let's talk about load balancers. They are a really important part of how cloud platforms work. Think of them as traffic managers for your applications. They sit in front of multiple servers and make sure that requests are distributed evenly across those servers to prevent any one server from getting bogged down. Cloud platforms like AWS, Azure, and GCP automatically handle this process. They'll add or remove servers based on how much traffic you're seeing, constantly checking if each server is healthy and redirecting users away from failing ones. They even have different methods for distributing the requests, so it's always optimized for performance and reliability. Okay, let's talk about IAM, identity and access management. It's absolutely vital for keeping your cloud resources secure. Think of it as how you control who can do what in your cloud environment. You'll need to define users and groups, maybe a team working on a project or individual developers. Then, you'll assign roles to those users or groups, which essentially bundle permissions together. Finally, policies at the really granular level, they dictate exactly what actions someone can take against specific resources like databases or storage buckets. Each cloud provider has its own service. AWS has EM, Azure uses Azure Active Directory, and GCP leverages Cloud IAM. Each of these services offers powerful features, but understanding the basics is key. And always keep in mind the principle of least privilege. Give people only the permissions they absolutely need. Okay, let's talk about MFA, multi-factor authentication. It's essentially like adding extra security checks to your cloud accounts. You already know your password, right? That's the first thing. But MFA goes a step further by requiring something else like a code sent to your phone or a fingerprint scan. This makes it much harder for someone who steals your password to actually log in. It's a really simple way to significantly boost your cloud security posture. Okay, let's talk about storing files in the cloud. We're going to cover AWS S3, Azure Blob Storage, and Google Cloud Storage. They all essentially do the same job, providing a place to put your digital stuff, images, videos, documents securely and reliably. Think of them as giant online filing cabinets that automatically scale up or down as you need them. They're really useful for anything from website assets to backups. S3 is Amazon's offering and is often the first one people learn about. Azure Blob Storage is Microsoft's equivalent, and Google Cloud Storage is GCP take on things. They all have their own strengths. S3 has been around the longest. Azure plays really well with other Microsoft tools, and GCP is known for its speed and cost effectiveness. It's worth understanding what each one offers when choosing a cloud platform. Okay, let's talk about securing your cloud storage. It's absolutely critical you don't want data breaches. In Oz, you'll use IAM roles and bucket policies to fine-tune who can access what. Don't forget server-side encryption with KMS for both transit and at rest. Azure uses RBAC and ACL, similar in concept. And GCP utilizes IAM roles and service accounts. Think of them as how applications will access your storage. Key management is important too. Oz has KMS, Azure has Key Vault, and GCP has Cloud KMS or Customer Managed Keys. Versioning and lifecycle rules are also key best practices for keeping things organized and secure. Okay, let's talk about VPC and VNets. They're super important when building cloud infrastructure. Essentially, a VPC or VNet is like creating your own private network inside the bigger public cloud. AWS calls it a VPC, Azure uses VNet, and GCP has its own VPC. They all achieve the same goal, isolating your resources for better security and control. Each provider has slightly different strengths. AWS is generally considered the most mature with lots of integrations. Azure excels at connecting to existing on-premise setups, and GCP shines when it comes to hybrid cloud scenarios. The key thing to remember is that you manage all the networking aspects like IP addresses, how traffic flows, and security rules within your VPC/VNet. Okay, let's talk about networking in the cloud, specifically subnets. Subnets are like isolated networks within your larger virtual private cloud, whether it's AWS, Azure, or GCP. Each of these platforms, VPC in Oz, VNet in Azure, and VPC in GCP, provides a way to logically separate resources. You need to understand CIDR blocks. Each subnet needs a unique one to avoid conflicts. Now, all three providers have slightly different terminology, but the underlying concept is the same, defining address spaces for your networks and controlling how traffic flows through them. AWS uses internet gateways for public subnets, Azure has network security groups, and GCP utilizes cloud firewall rules. It's important to be familiar with these components. Okay, let's talk about serverless computing. It's a really important concept in the cloud world. Essentially, with serverless, you don't have to worry about managing servers yourself. AWS has Lambda, Azure has functions, and Google Cloud has cloud functions. They all offer similar core ideas. You write your code, upload it, and the platform automatically scales it up or down as needed based on demand. You only pay for what you actually use, making it incredibly cost-effective. It's a huge shift in how we think about building applications in the cloud. Let's talk about serverless functions. These are a really powerful way to build cloud applications without worrying about managing servers. AWS Lambda, Azure Functions, and Google Cloud Functions all do essentially the same thing. They are event-driven compute services. This means they only run when something happens, like a file being uploaded or an HTTP request coming in. You only pay for the time you actually use them, which is great for cost efficiency. They are also stateless by default, so each function execution is independent. AWS Lambda is Amazon's choice, and it integrates really well with the rest of their ecosystem. Azure Functions are Microsoft's offering, and they're fantastic if you're already invested in Azure. And Google Cloud Functions provides a similar experience within Google Cloud Platform. Each has its strengths, but understanding these core concepts will help you tackle many interview questions. Let's talk about how databases work in the cloud. Basically, instead of you taking care of all the server stuff and database maintenance, a provider like AWS, Azure or GCP handles that for you. It's like renting a fully managed service. They handle updates, backups, security, and even scaling your database up or down as needed to match your business needs. You get access to different types of databases too, from traditional SQL databases to new NoSQL options, and the best part is you only pay for what you actually use. Okay, let's talk about databases in the cloud. All three major platforms, Azure and GCP, offer managed database services. Amazon RDS is a really versatile option. It supports many different database types like MySQL or PostgreSQL. Azure SQL Database is a strong choice if you're already using Microsoft products. And Google Cloud SQL provides similar capabilities for those using the Google ecosystem. Essentially, they handle all the complex administrative tasks so you can focus on building your application. Okay, let's talk about CDN. They're a really important part of building fast and reliable web applications. Basically, a CDN is like having copies of your website's static files stored in multiple locations around the globe. When someone visits your site, instead of always fetching everything from your main server, the CDN serves it from the closest location. This dramatically reduces loading times, especially for users who are far away. AWS CloudFront uses edge locations within its network, Azure leverages its global points of presence, and Google Cloud utilizes its massive infrastructure. Each has its own strengths and features, but they all achieve the same goal: delivering content quickly to your users. Let's talk about CDN. They're super important for delivering a fast user experience. Think of them as mini servers spread out around the world. AWS CloudFront is a really popular choice, especially if you're already using other AWS services like S3. Azure CDN works great within the Microsoft ecosystem, and Google Cloud CDN utilizes Google's massive global network. Each one offers similar core functionality, caching your content closest to your users to reduce load times and improve performance. Okay, so let's talk about how you tackle monitoring and logging in the cloud. It's absolutely vital to keep an eye on what's going on with your applications and infrastructure. The core idea is to gather data from everywhere, all those moving parts, and then use it to spot problems before they become big issues. First, you want a central place to collect everything, like CloudWatch logs in AWS or Azure Monitor logs. Then, you'll need to grab performance metrics: how much CPU is being used, how much memory, network traffic, and set up alerts so you're notified if something goes wrong. Each cloud provider has its own tools for this, of course, but the fundamental principles are pretty similar. You can see a quick overview in this table: AWS CloudWatch, Azure Monitor, and Google Cloud Logging and Monitoring all offer powerful ways to monitor your systems. Let's talk about how these cloud providers keep a close eye on their services. It's called monitoring. AWS CloudWatch is like the central hub for collecting data from all your Amazon resources, tracking things like CPU usage and network activity. Azure Monitor does something similar, using log analytics to gather logs and Metrics Explorer to visualize performance. And Google Cloud Operations, formerly Stackdriver, offers tools like Cloud Monitoring and Cloud Logging, plus Cloud Trace, which is great for pinpointing where slowdowns are happening in your applications. Okay, let's talk about getting your data and applications safe in case of a disaster. All three major cloud providers, Azure and GCP, have robust options. AWS offers things like S3 Glacier for long-term backups, replicating your databases using Aurora, and even a fully managed disaster recovery service called Doctors. Azure has geo-redundancy zones to spread your resources across different availability zones within a region, plus tools like availability sets and Azure Site Recovery. And Google Cloud Platform provides regional persistent disk replication, offers various storage tiers for archiving data, and also has its own disaster recovery service. Thinking about how these options fit your specific needs is key. Let's talk about resource tagging. It's a really important piece of the cloud puzzle, especially when you're managing costs effectively. Think of tags as labels that help you understand what each resource asterisk is asterisk and who owns it. They aren't just random words. They're key to things like accurately tracking expenses, ensuring your team is following policy, and making it much easier to find exactly what you need when you need it. A good tagging strategy means creating a consistent approach across the board. Think about what's important for your organization, like department or project name, and then build from there. Let's talk about what makes a cloud-native application tick. These aren't just apps you shove into the cloud. They're built asterisk for asterisk it. We're talking about breaking down large applications into smaller, self-contained pieces called microservices, like Lego bricks that work together. They often live inside containers, which is like packaging everything an app needs to run neatly and consistently across different servers. And critically, they embrace DevOps, automating the whole process from building to deploying so updates happen quickly and reliably, and they are built to handle unexpected spikes in demand and failures without a hitch. Okay, let's talk about how we keep our cloud infrastructure consistent and reliable. A really important skill in the cloud is managing configuration, essentially making sure everything is set up exactly as it should be and that it stays that way. We usually do this using infrastructure as code, which means defining our infrastructure with code instead of manually clicking through interfaces. Tools like Terraform are super helpful here for writing that code. Then, we often use dedicated configuration management tools, Ansible, Chef, or Puppet, to actually apply those configurations and ensure everything is in the desired state. And don't forget about the native services offered by each cloud provider: AWS CloudFormation, Azure ARM, and Google Cloud Deployment Manager. These all let us create templates for easy deployment. Okay, let's talk about containers and how they fit into the cloud world. Imagine a container as a really efficient little box. It holds everything an application needs to run: its code, its tools, everything. It's much lighter than a traditional virtual machine because it shares the host operating system kernel, making things incredibly fast and portable. Containers are great because you can move them easily between different environments. But managing lots of containers gets tricky. That's where container orchestration comes in. Services like Kubernetes help automate all aspects: deploying, scaling, and even restarting your containers automatically based on demand. Think of AWS ECS or Azure Container Instances as ways to use these services within their respective cloud platforms. Okay, let's talk about the managed Kubernetes offerings from AWS, Azure, and Google. First up, Amazon XX. It's all about security. It uses hardware security modules to protect your cluster secrets and credentials, adding a really strong layer of defense. Next is Azure AKS, Microsoft service. It's fully managed, so they handle a lot of the operational headaches for you. And finally, Google Kubernetes Engine, or GKE. It's known for its performance and integration with all the other Google Cloud services. Knowing these differences will definitely help you in your interviews. Let's talk about getting your code changes out there quickly. That's where CI/CD comes in. When deploying applications on AWS, Azure, or GCP, you'll want to consider the specific services each platform offers. AWS has code pipeline and related tools, Azure uses Azure DevOps, and Google Cloud Platform leverages Cloud Build and Deployment Manager. A typical CI/CD pipeline starts with a code commit, then kicks off automated builds and tests. If everything checks out, it moves into deployment, often using infrastructure as code to manage your environment automatically. Finally, you'll want to monitor the application to get feedback for future improvements. Okay, let's talk about how these cloud providers handle continuous integration and continuous delivery. First up is AWS Code Pipeline. It's a really user-friendly way to connect all your development tools like source control and build servers and automate the release process across the whole AWS ecosystem. Then we have Azure DevOps, which is a bigger suite of services. Azure Pipelines handles the automation piece and uses YAML for defining those pipelines. Finally, Google Cloud Build provides a flexible build service that can be triggered by various events and supports a huge range of languages and platforms. It's perfect for automating your builds on Google Cloud. Okay, let's talk about managing infrastructure as code in the cloud. It's a really important skill for any cloud engineer or DevOps professional. There are several popular tools you'll encounter. Terraform is king across platforms, but AWS also has CloudFormation and Azure has ARM templates. Google Cloud offers Deployment Manager alongside Terraform and Pulumi. The key things to remember are version control with Git absolutely critical. You need tests to make sure your code works as expected, and a way to manage the state of your infrastructure so everything stays consistent across different environments. Security is also paramount. Always follow the principle of least privilege and use secure methods for storing secrets. Okay, let's talk about how these cloud giants handle creating and managing their infrastructure. All three O's, Azure and Google, use a powerful concept called infrastructure as code, or IC. This means you define your entire environment using code instead of manually clicking through the console. AWS uses CloudFormation. It's like a recipe for building your infrastructure using YAML or JSON. You write out exactly what you need, and CloudFormation takes care of the rest. Azure has Azure Resource Manager, which is pretty comprehensive for managing multiple resources across their whole platform. And Google offers Google Deployment Manager, again leveraging code to automate the creation of their cloud services. Okay, so when it comes to securing your cloud platforms, whether you're using AWS, Azure, or GCP, there are some really important things you need to keep in mind. First off, think about identity and access management, basically giving people only the access they absolutely need. Then, encrypt your data both when it's stored and moving around is a must-do. Next up, network security, properly segmenting your network with firewalls and keeping an eye on traffic. Don't forget logging and monitoring. You need to be able to spot anything unusual happening. And lastly, make sure you're following all the relevant regulations and have clear security policies in place. Cloud security is ongoing, so continuous checking and adapting are vital. Let's talk about managing API in the cloud. It's a really important part of building modern applications, especially when using services like AWS, Azure, or Google Cloud Platform. Each provider has its own approach, but they all offer powerful tools. AWS uses Amazon API Gateway. It's a fully managed service that lets you create and secure your API with ease. Azure has Azure API Management, which integrates really well with their other services for security. And Google Cloud offers cloud endpoints primarily focused on exposing backend services through API. No matter what you choose, think about things like how you'll handle authentication, rate limits to prevent abuse, versioning so you can manage changes safely, and good monitoring and logging so you can spot any problems quickly. Okay, let's talk about how these cloud giants handle your API. AWS API Gateway is like a superpowered front door for your applications, letting you easily connect to your backend services with REST, WebSocket, or even HTTP API. It's packed with features like throttling and security. Azure API Management is similar but offers broader protocol support. Think REST, SOAP, and GraphQL, and strong policy enforcement. Finally, Google Cloud Endpoints uses open API definitions to quickly build secure API, generating client libraries for you in multiple languages and integrating seamlessly with the rest of Google Cloud. Okay, let's talk about cloud marketplaces. Basically, they are like online stores specifically designed for the cloud. Think of it as Amazon or Etsy, but instead of selling shoes and crafts, it sells pre-built software, databases, analytics tools, everything you need to build applications and solve business problems in the cloud. Major providers like AWS, Azure, and GCP all have their own marketplaces. You can use them to quickly find and buy services without having to negotiate individual contracts with vendors. It also helps speed up deployment because many of these solutions are ready to go. And you'll often find third-party vendors offering integrations that make your cloud environment even more powerful. For example, a marketing team might use it to get a CRM system set up really quickly, or an engineering firm could leverage AI/ML services for data analysis. Let's talk about how you get charged when using cloud platforms. All three AWS, Azure, and GCP operate with a pay-as-you-go model, meaning you only pay for what you actually use. However, the details can vary quite a bit. AWS is really granular. You're breaking down costs by specific services like your EC2 instances or S3 storage. Cost Explorer is their powerful tool for seeing exactly where your money is going and analyzing trends. Azure offers a similar experience with cost management, helping you set budgets and get alerts if things are rising too quickly. And GCP also utilizes billing tools to track spending, offering discounts like committed use discounts and sustained use discounts. These can be significant savings if you plan to use resources for an extended period. Okay, let's talk about shared responsibility, a really important concept in cloud security. Essentially, it means that keeping your data and applications safe isn't just the cloud provider's job, you have responsibilities too. Think of it like renting an apartment versus owning a house. The landlord handles the building's security, the infrastructure, but you are responsible for securing your belongings within it, locking your doors, installing alarms, etc. The cloud providers secure the underlying stuff, the servers and networks. But you have to make sure your applications, data, and access controls are done right. It's a crucial partnership. Let's talk about how you'd handle compliance when using cloud platforms like AWS, Azure, or GCP. It's a really important part of deploying applications securely and legally. You need to understand the regulations that apply to your business, things like GDPR for data privacy, HIPAA if you're in healthcare, or CCPA depending on where you operate. Each cloud provider offers their own certifications. AWS has ISO 27001 and FedRAMP. Azure has ISO 27001 and do deprovisional, and GCP is SOC 2 type Roman 2. Remember the shared responsibility model. The cloud provider secures the underlying infrastructure, but you're responsible for securing your data within it. So, you need to assess what regulations apply, use the security tools provided by each platform, implement strong controls like encryption and access management, and keep really good records of everything you do. Okay, let's talk about multi-cloud environments when you're using AWS, Azure, and GCP all at the same time. It's a really common situation now, but it comes with some unique challenges. The first thing to think about is keeping your data consistent across all those different places. How do you make sure everything stays in sync? Then, you need a way to manage identities so users can log in and access resources the same way no matter which cloud they're on. And of course, getting these clouds to talk to each other securely through networks is super important. Finally, robust monitoring, being able to see what's happening across all those platforms, that's key to managing it effectively. Let's talk about hybrid clouds. Basically, it's like having your own data center, but you also tap into the power of public cloud providers like AWS, Azure, or Google Cloud. It's not necessarily about switching to one provider, it's more about picking the best tool for each job. For example, if you have strict regulations around where your data needs to live, maybe because of compliance, a hybrid approach lets you keep the sensitive information on site while using the public cloud for less critical workloads, like things that need extra processing power during busy times. It's also really handy when you need to quickly scale up resources, like during a sales promotion or holiday rush. And if you have older applications that are difficult to move completely, a hybrid strategy can let you migrate them gradually, piece by piece. Okay, let's talk about moving your workloads to the cloud. This is a really important skill, and it's not just about dragging things over. First, you need to take stock of what you have, how much data, which applications are running, and what their needs are. Then, figure out why you want to move them and decide on a strategy. There's lift and shift, where you move things as is. Then there's replatforming, where you make some improvements without huge changes, or even completely rebuilding your applications. It's important to start small with a pilot project before rolling everything out at once, and always keep an eye on performance and security after the migration. Okay, so let's talk about how we actually move things to the cloud. Each of the big players, AWS, Azure, and GCP offers a whole suite of tools designed to make this process smoother. AWS has Migration Hub, which is like your control center for everything migration related. Then there's Server Migration Service, really good for moving servers around, and Database Migration Service handles databases with minimal downtime. And Cloud Endure is an option if you need extra automation. Azure brings in Azure Migrate to help assess what you can move, plus Database Migration Service and Site Recovery for disaster recovery and replication. Finally, GCP offers its own Migration Hub, Compute Engine Migration Service, and a Database Migration Service, all designed to work together effectively. It's important to think about which tools best fit your current setup and priorities when planning your cloud migration. Okay, so let's talk about what can go wrong when you're moving to the cloud. It's not always as simple as just hopping over. You could easily end up with unexpected costs if you don't plan carefully. Security is a big one too. Making sure your data stays safe in this new environment takes serious thought. Then there's the skills gap. Often teams aren't familiar with managing cloud services and how to keep things running smoothly. And, of course, some applications just won't move easily without some significant changes. Finally, moving all that data can be a real headache. To avoid these problems, you need a solid plan, strong security practices, and people who know what they are doing. Thank you for watching.